This chapter will present you the main differences between the two variants in terms of limitations and operations. The various values mentioned may vary according to a given aircraft, so please refer to your airline documentation to get more accurate figures. The center of gravity limits are available in FCOM Volume 3. On the A340-600, limits are between 12 and 45%. The weights are given for a basic aircraft and may vary according to airline customization. Refer to the airline documentation. V approach speed at max landing weight in Conf full results in approach minima category D, assigned to the A340-600. The A340-600 standard operating procedures are similar to those on A340-300. There are only minor differences on some system panels due to new systems equipment. Hydraulic overhead panel, fuel panel, air conditioning panel, ISIS, Integrated Standby Instrument System, TACS, Taxi Aid Camera System panel, Nose Wheel Steering Brakes panel, engines, ECAM pages. In addition to the standard A340 inspection, you have to check the condition of the TACS camera, located under the belly of the aircraft. On the left-hand side of the engine, check that the following doors are closed: starter valve access door, IDG access door. On the right-hand side, check that the oil tank, master magnetic chip detector, and TR inhibition access door is closed and latched. On the center landing gear, the brakes and brake wear indicator condition. The starting sequence is fully automatic and identical on both variants. However, the engine start monitoring is slightly different. Refer to Power Plant module. Start attempts are limited according to the following logic. First start 3 minutes, second start 3 minutes, motoring 1 minute, cool down 30 minutes. Once the third engine has been started, the pitch trim is automatically set to the value inserted in the MCDU init page. We are now ready to taxi. A new system called Taxi Aid Camera System, TACS, has been designed in order to facilitate ground maneuvers on the A340-600. Let's first take a look at the geometry of the aircraft. Notice that the pilot is seated at 4.3 meters, 14 feet from the nose landing gear. The minimum pavement width for a 180 degrees turn with symmetric thrust and no braking is 59 meters, 193 feet, calculated with a nose wheel steering limit angle of 76 degrees. The A340-600 180 degrees turn must be done on the turning pad. The TACS provides the pilots with visual information on the position of the landing gear in relation to the taxiways and runways by means of cameras installed on the aircraft. There are 2 cameras, one located under the fuselage, belly camera, and the other on the fin leading edge, vertical stabilizer camera. These cameras send visual information to the cockpit, on the PFDs and system display on the ground, and only on the system display in flight. Note, at a ground speed greater than 60 knots, the tax is automatically inhibited on the PFDs. The crew can select which screen will display the pictures by means of the camera control panel located on the pedestal. As soon as any taxi selection is made, a green Taxi Camera memo is displayed on the engine warning display. Note, a switch is installed outside the aircraft for tax deactivation. If needed, the crew can use the additional lighting dedicated to the tax. This function is controlled by the runway turn-off and camera selector located on the external light overhead panel. As soon as one of the taxi aid camera selectors is in the taxi position, with the runway turn-off and camera switch in the on position, 3 lights on each side of the fuselage and 1 light on each lower wing illuminate the landing gear and the surrounding ground as follows. The image is divided into 2 parts. 1/3, the upper part, shows the nose landing gear and its surroundings. 2/3 shows the aircraft seen from the fin leading edge. On the upper part, a ground speed, GS, calculated by the GPS, is displayed in the top left corner of the image. The squares represent a reference mark for turning. On the lower side, magenta lines materialize 1.5 meters, 4.92 feet, outside of the outer edge of the main landing gear. We will now show you examples of taxiing. Notice the tax is only designed to aid the pilot in determining the location of the nose and main gear wheels prior to or during turns while taxiing. It is not designed to taxi the aircraft. The tax can help you during pushback in checking that the tow truck is connected and the aircraft environment is clear of obstacles. Ground crew personnel are at the appropriate position. The recommended maximum taxi speed is 30 knots, straight. Magenta lines allow you to taxi with an appropriate margin from the outside area of the taxiway. If you taxi with landing gear at the edge of the taxiway, as shown here by the video, observe that magenta lines are outside the taxiway. The maximum taxi speed for turning is 10 knots. Use oversteering techniques to start the turn. Initiate your turn using outside references. The tax can help you to control the amount of oversteer required to maintain the main landing gear on the taxiway by keeping the wing root or the magenta square on the yellow center line all turn long. Note, to see all the information contained in this video, replay it several times. Warning: if insufficient oversteering is used during turns, the main gear may run outside the taxi surface. We will now show you a 120 degrees turn. Observe the same technique and reference marks are used as for the 90 degrees turn. Note, as for the 90 degrees turn, Airbus recommends you to review this video several times. Warning: as for the 90 degrees turn, if insufficient oversteering is used, The main gear may run outside the taxi surface. Let's now see a 180 degrees turn. Use the same technique to enter the turning pad. Initiate the turn using external references and maintain taxi speed around 8 knots using asymmetrical thrust. Do not exceed 1.05 EPR on outboard engines. Note, asymmetrical thrust may be used during turns at high nose-wheel steering angles in order to initiate the turn and to keep the aircraft moving during the turn, but it should not be used to tighten the turn. Notice that for any alignment, oversteering technique must be amplified in order to minimize the amount of runway used. Note, takeoff performance computation takes into account 25 meters, 82 feet, TODA, for a 90 degrees alignment, and 61 meters, 200 feet, TODA, for a 180 degrees alignment. Takeoff speeds are given for a runway of 3,500 meters, standard atmosphere, no wind condition at max takeoff weight. To get the customized values, refer to your flight manual. The takeoff power application is similar on both variants. It is done in 2 steps. First set 1.05 EPR on all engines, Trent engines being controlled in EPR mode. Then apply takeoff power, flex, derated or toga. As soon as the thrust levers are in flex or toga detent, the pitch attitude limit indicator will appear on the PFD. The rotation technique is identical. Refer to FCOM 30427. Pitch attitude target. On A340 300, 12.5 degrees. On A340 600, 15 degrees. Note, the sensory feedback to the pilot during the rotation may be different due to the length of the aircraft and its flexibility. 1 out of 2. Since the aircraft is longer, for a same rotation rate, the local vertical acceleration sensed by the pilot is higher. 2 out of 2. This effect is increased by the flexibility of the aircraft. First, the pilot senses a delay in the rotation. Then, the local vertical acceleration sensed by the pilot is further increased. This sensory feedback should not lead to overreaction by making large changes to the side stick inputs. The pitch attitude limit indicator provides the maximum attitude not to be exceeded in order to avoid a tail strike. The pitch attitude limit indicator is set at 9.5 degrees while on ground and increases up to 14 degrees after liftoff. It disappears 3 seconds after liftoff before reaching the 15 degrees pitch attitude target. Caution: never set toga power when using derated takeoff. Tail strikes can occur in case of early rotation due to erroneous VR computation or when the rotation is initiated before VR. It could also occur in case of excessive initial rotation rate, too abrupt, or when the rate of rotation is suddenly increased when reaching 8 degrees of pitch. The best configuration for tail clearance is Conf 3. Initial takeoff climb, acceleration phases are identical. The logic for slats flaps retraction is the same, but a value has been modified. Flaps auto retraction speed 215 knots instead of 200 knots. Note, landing gear speeds VLE, VLO 250 knots 0.55. After a takeoff at maximum weight, let's compare a climb to flight level 200 at max climb thrust between the A340-300 and the A340-600. Then a climb to flight level 310. Operation of both variants is similar. Due to RVSM requirements, the altitude alert has been modified, plus or minus 200 feet instead of 250 feet, but will be retrofitted on the A340-300. FANS operations are described in a separate module. The slats flaps limiting speeds are different between both aircraft. VREF speeds are higher on the A340-600 because of the higher weight. Due to inertia, it is more difficult to decelerate an A340-600, and you will need more anticipation when establishing the landing configuration. At 400 feet RA, the pitch attitude limit indicator appears on the PFD. It indicates 10 degrees of maximum pitch attitude not to be exceeded during flare and touchdown. The pitch attitude limit indicator disappears in case of go-around when thrust levers are moved to toga. The landing technique is similar on both aircraft. However, the risk of tail strike is higher on the A340-600. The tail clearance is lower on the A340-600. A tail strike can occur if pitch attitude exceeds A340-300 10 degrees oleo compressed or 14 degrees oleo extended, A340-600 8.4 degrees oleo compressed or 11.7 degrees oleo extended. Below 14 feet RA, a call-out pitch, pitch is automatically triggered in case of excessive pitch attitude to avoid tail strike. Remember that tail strikes occur if V approach is decreased below the calculated one, high pitch attitude, high flare with engines reduced to idle power, pitch attitude is increased to avoid sink rate, attempt to touch down too smoothly, increased pitch attitude, pitch up after a bounce to avoid a second hard landing. Other differences include actual landing distance, max tire speed 205 knots instead of 195.5 knots, maximum crosswind TBC 27 knots gusting up to 33 knots.